Yeah. All right, now we have a problem though, because this is going to give us a quadratic equation for a quadratic formula. Well, remember that usually in your class you're allowed to use approximations.
For 400.
Yeah. So what would be the approximation that we could use here?
That it's 0.1 just equals the x equals or will be close to 0.1.
So how would I change this?
We just multiply by 0.1. I mean,
yeah. So the point here is, remember that we don't expect this to be very soluble now, right?
Mm-hmm.
Especially with the common ion effect. We don't expect this to be very soluble. So we expect that the amount that dissolves is probably going to be pretty small relative to the amount that we started with. So instead of saying 0.1 plus x, we can just approximate that as 0.1 times 2x squared equals 6.5 times 10 to the negative 6. So we'll go ahead and make that approximation. Usually in your class you can make approximations to avoid the quadratic formula. Good?
Okay. So it's going to be then 0.1 multiplied by 2, 0.1. It's going to be squared.
Now let's think about this step a little bit. How are we approximating here? Well, we're approximating that x is much smaller than 1, right? So if x is much smaller than 1, 0.1 plus x is approximately the same as 0.1. But that approximation has no effect on this term. This is a multiplication, not an addition. We can only make these approximations for additions, not for multiplications. So we're not plugging in 0.1 for x. We're not plugging in 0.1 for x. All we're saying is that 0.1 plus x is approximately the same as 0.1. But that doesn't change this term at all. This term will still be the 2x squared.
So 0.1 plus x is actually, that's what we're approximating.
Yeah,
just
we're approximating that the
x.
0.1 plus x will probably be pretty close to 0.1.
So it's going to be 0.2. So it's going to be x will equal 0.04, which is less than 0.1. I mean, which is kind of less our predictions for x. Yeah.
One sec. Oh, okay. This should be 0.4.
Yeah, that's what I thought, but then I looked up the keywords.
That's what happens when I'm going too quickly. You
and
should
I
be more
saw
careful.
that you lost, I lost the 0 because I put first 0.4.
All right, so let's try again. 0.1 times 4 is 0.4. So now I would have 6.5 times 10 to the negative 6 divided by 0.4. That's 1.625 times 10 to the negative 5th, right?
But you had the right answer before because you had the 1.625 to the 10.
So then I do square root of 1.625 times 10 to the negative 5th.
And then it's going to be 0.04. Is it?
That looks better. So that is 0.004 molar?
Molar, yeah, because...
Good. Okay, so what's the answer to the question?
0.004 molar.
Because the question was asking us for the molar solubility, and we said that X was the molar solubility. Does that match our prediction?
Yeah.
Remember that the old solubility was 0.012. Well, this is a lot smaller than 0.012. So again, because we've already dissolved so much calcium from the calcium nitrate, that we can only dissolve a little bit from the calcium hydroxide. Was our approximation make sense? So notice, is 0.004 really a lot smaller than 0.1? Well, yeah, 0.1 plus 0.004 is just 0.104. It's hardly any different, so that's a fair approximation to have made. So we've kind of proven here, or given an illustration of the common ion effect. Okay, well now we've gone through the three types of problems that you're likely to see on the test. Again, in this case, we were given the KSP and we were asked for the molar solubility, but this was trickier because there was a common ion. So let's review the technique for this. So in this case, because there was a common ion, first we had to dissolve the common ion. First you have to write the equation for the dissolution of the other substance. How did I know to start with this substance? Well, this one was easier because I know this is completely soluble. It makes sense to start by dissolving the substances that are completely soluble. So that's a good rule. If you've got more than one substance, you should start by dissolving the substances that are completely soluble, because those are the easier equations. And we know that nitrate is one of the ions that's completely soluble, along with sodium and potassium. So we started by completely dissolving this.
Okay.
And then we can just use our normal method. Now we can dissolve the substance that the question is about. But now we have our starting amounts come from the ending amounts from the previous equation. Now your first instinct here was that at first you were trying to react these two things with each other. And that just turned out not to be the correct thing. Now that might have made sense for acids and bases. I can see why you would think that, because with acids and bases we do react the acids with the bases. But remember that we're not thinking of these salts as reacting with each other, we're just thinking of them as dissolving. So there's no way they can react with each other. All they can do is dissolve.
Okay.
So if you have more than one salt, you just have more than one dissolution reaction. And which one should you write first? The one that's the simpler one, the one that's going to completely dissolve. And then you can analyze the one that's more complicated, the one that is not completely soluble. And then we went through. Once again, you might need to make approximations like you did for acid-base problems. So watch out for those approximations. And again, we noticed that the number 2 here played 2 roles. It gave us a coefficient of 2, but it also gave us an exponent of 2. I think we were being pretty careful with that. Well, I think it would be good before the test to try to redo the 3 problems that we just did, because they got progressively harder. These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm. Or you can just use the link in the info box. Thank you.